What is up? Welcome to the video. This time, the video is about a new reaction, and this reaction is called double replacement reactions. In a double replacement reaction, we're dealing with two compounds now, and in those compounds, we're going to be looking for the metals or the cations, the positively charged ions of the two compounds to switch places, and this is going to produce two new compounds. Now, something special about double replacement reactions, which most of you should have been able to experience in a lab, was that we're looking for a solid or a precipitate to be formed. So generally in our ionic aqueous solutions, we're going to combine those two aqueous or liquid solutions to form a precipitate or a solid. Now, there is one exception to that, which I'll make sure that we see. And in a case where we react two things and one of the products that comes out is water, H2O, that is also considered a precipitate, but in this case it is a liquid precipitate. So we always want to make sure that we are finishing our reaction and that the products of our reaction contains one solid, sometimes a liquid, and some sort of solution. Now, just like our single replacement reactions, we need to use a specific tool, and that tool is what is called the solubility rules chart. And on this chart, what we can basically do is we can look at any combination of ions, both positive on the vertical column and negative on the horizontal column, and we can connect or see where those two things intersect when they form a compound in order for us to determine whether it's going to be a solid or an aqueous solution. And you guys will be able to use this on any test, any homework assignment, anything pertaining to double replacement reactions. You will be able to use this chart just like the activity series. So the way this works, if we're looking at our first example, hopefully you're following along in your packet. These are the same examples in your packet. You will find we have AgNO3. Ag is silver. So silver is right here. Let me see if I can highlight my pointer for you guys. Turn on laser pointer. There we go. So we have silver, and then we are combining that with NO3, which is nitrate. If I go ahead and try to find nitrate, everything's alphabetized here. So nitrate is here. When we make that intersection, we see that silver nitrate, AgNO3, has the AQ in that box, indicating that silver nitrate would form a solution. So in the case that we combine silver and a nitrate ion, we know that that would form some sort of solution. So for the next one, K2PO4, we've got potassium. Potassium is right here. Then we have PO4, that name is phosphate. Phosphate is right here. So when we go to potassium phosphate, again, we see we've got ourselves an aqueous solution. So hopefully we're starting to pick up on this. Pretty easy, just find where the 2 points meet, and that will tell you what state of matter there are. So for the next one, we've got Na2SO4. Na is sodium. SO4 is called sulfate. Sulfate is down here. Sodium is second to the bottom. So again, another aqueous solution. So it looks like I wasn't too diverse in the way that I was giving you guys examples here, but that's okay because all it really is practicing using the chart, and we'll be able to see at least one solid on this list. All right, barium chlorate, barium chlorate, a few over. That is also aqueous. Hopefully we're catching on here. Last one, aluminum and hydroxide. There we go. Aluminum combining with a hydroxide ion, OH, that is a solid. So we would indicate that as a solid. So this is obviously a skill that we will practice, or a skill that we need to be able to do, but all of that is meant for the bigger picture, which is predicting the products of a double replacement reaction. So we will use this to predict those products and identify if a reaction does or does not take place. So let's go into some examples. These examples are in your packet. These examples are on page 13. And I'm going to show you guys a couple of those examples just so you can see how they work. And then hopefully you'll be able to try some of them on your own. So here we have two examples. I got a reminder up here on the top. We're always going to start with two aqueous solutions, but we're going to be looking for a solid and a solution to be formed to indicate that a reaction took place. Now, in the case where we have two of our solutions combined and we get two solutions out of that, that would be an indication of no reaction. And we would treat that just like a single replacement reaction where we would just write no reaction to indicate that nothing was precipitated or no solid was formed. I also have the solubility curve or the solubility chart here, just for reference, because we're going to want to be able to use that for the purpose of determining states of matter. You guys have one in your packet, and that is located on page 12. So make sure you have that out or have that handy, and that way we can be successful in doing these. So let's take a look at this first one. In this first example, we have HCl aqueous reacting with NaOH, also aqueous. We first need to figure out what things are going to be switching places. We said that the cations or the positively charged things are going to be switching places. In this case, it's always going to be the first part of our ionic compound. So our first thing that we're going to produce is a sodium now being attached to the chlorine. And yes, this does require the crisscrossing of charges. Sodium forms a positive 1 charge. Chlorine forms a negative 1 charge. So to produce that compound, we're going to crisscross those charges, and that's going to give us NaCl. So the first product that we produced was NaCl. Now let's see what the state of matter is, or whether it's a solid or a solution. When I hold that up, we find sodium down towards the bottom. Chloride is this column right here. So as we trace that down, it looks like that lines up with the AQ or aqueous symbol. So we've got one aqueous solution that is being produced. And then what we're going to be looking for is the final product, which is a combination between hydrogen and an OH group. Hydrogen forms a positive 1 ion. Hydroxide, OH, forms a negative 1 ion. This is a polyatomic ion on the back of your periodic table. So when I crisscross that, it is HOH. Now, HOH can also be written in a more familiar way, H2O. There's 2 hydrogens there and 1 oxygen. So it's the same formula. It just kind of rearranged a little bit differently. So I'll just leave it as HOH just because, to keep things a little bit straightforward and simple. But we know that water at room temperature is a liquid. So I'm going to put liquid there to indicate that we did precipitate something other than a solution in our reaction. And I know that it says solid and solution, but if I add an L here to indicate that we're going to also maybe be looking for a liquid, this one would be an indication or an example of a double replacement reaction where we did precipitate something out. In that case, we produced water in that reaction. So in this reaction, this one does take place because we did form a liquid precipitate of water, and we also had a solution being formed. So that indicates that a reaction did take place. Now, of course, the last step is to always make sure that the equation is balanced. 2 hydrogens, 2 hydrogens, 1 chlorine, 1 sodium, 1 oxygen, 1 oxygen. Boom, there you go. Already balanced. So we could put 1s in the blank, or we could just leave it as is. I think we'll just leave it as is because I think it looks a lot better that way. All right, so that was our first example of being able to predict the products of a double replacement reaction, as well as identify if that reaction took place. And the reason it did was because we had that liquid precipitate formed out of 2 solutions. All right, let's see what we can do about this second one. Maybe the second one will look a little bit different. So we've got sodium chloride. Sodium is our cation there. Potassium nitrate. Potassium is our cation there as well. So in this reaction, we're going to be looking for these 2 elements to switch places with each other. When they do, that's going to form first a compound containing a potassium ion, which is K+1, combining with the chlorine ion Cl-1. We're just flipping the places where sodium and potassium are located. When I crisscross those charges, we see that our first product is KCl, also known as potassium chloride. Now, these states of matter are very important in a double replacement reaction. So we're going to find potassium. right here with a chloride, tracing that downwards. Looks like it is aqueous, AQ. I'll hold that closer so you guys can see that. Potassium, chloride, aqueous, right where my marker's pointing. So this is an aqueous solution, AQ. So that's one part of what we're looking for. Now let's just see if our second product also, what kind of state of matter that gives us. So now we're going to have sodium combining with the NO3, the nitrate. Sodium +1, NO3, that's a polyatomic ion as well, found on the back of your periodic table, -1. So in crisscrossing those charges, the 3 stays a part of that NO3, that's a nitrate, but the 1 is going to get transferred down, giving us the formula NaNO3. The 1s are just implied by writing that there. So our second product was NaNO3. So again, referring to our solubility rules, we've got sodium down towards the bottom. We've got nitrate right here. Tracing that down, it looks like sodium is also aqueous or AQ. Now, if you remember, we said that we're always looking for some sort of precipitate to be formed. But in this case, I only have 2 solutions being formed. So what we notice here is that we didn't precipitate anything out. So when we see something like this, we need to recognize, uh-oh, red alert, no reaction took place. So I'm just going to cross out my products and write no reaction. Just like we had in single replacement reactions, and just like we saw in the lab, when you combine 2 solutions, sometimes no reaction takes place. There's no solid form. We didn't see any color change. So in that case, we wrote no reaction. I just crossed out my products. You guys could also erase them if you want and just write no reaction. But I would like to see how you produce those products. So I'll always just cross it out and then write no reaction after it to indicate that no reaction took place. So if no reaction takes place, we don't need to balance, we don't need to do anything with it, we're good. And we can move on to the next one. So I hope that these 2 examples kind of give you an idea of how we're going to do this. And from there, we'll just continue to practice this and get a lot better with using the solubility rules and predicting the products of double replacement reactions. All right, we will see you guys soon. Hopefully you enjoyed the video. Hopefully it made sense and everything is going well for you, but I'll catch you in class next time. Peace.